Alright, so we're going to wander through this problem. Y equals 2 times square root of x minus x. I'm catching up the video. You should identify it as a composite function with a root and a polynomial. We should easily see that the root function is what sets the domain here from 0 to infinity. And the range we're going to have to say for later. And then taking the derivatives, I spend no time anymore talking about how to do it, right? We just do, especially when it's power functions. And we have to make a fractional exponents, and we have to take the division, the derivatives of each one. Now, the next thing would be finding the critical points, all right?
Mr. Anderson?
Yes?
I have a question. Go to y prime prime. Would the negative 1 be 0?
Oh, shoot.
Yeah, I was wondering why you put that.
Marley, bonus point, yeah. Can you guys, I am beat today.
I just on my Tyler, too, because he
Tyler, you too then, man. No, you guys are right.
and me.
And Nicole. I would say, I could lie to you like some teachers do and say, oh, I meant to do that to see if you're paying attention, but I just screwed up. And that would have been a horrible screw up, guys, because when we get the points of inflection, that one would have screwed it. I'd have figured it out probably, maybe. I don't know, I'm pretty tired.
I thought you put my because
Oh, minus 1. Yeah, I got cut. I want to find the critical points. Now, everybody, let's be clear about this. This is one thing on the test. Critical points are only when the first derivative is 0. All right? Critical points are only when the first derivative is 0 or undefined, okay? So I'm going to look at the first derivative, y prime there. I'm going to move these other parts out of my screen. All right? And we're going to move back up. All right. So I'm going to say 0 equals 1 over the square root of x minus 1. So I can definitely see when I move the 1 over, you guys see that 1's going to be a critical point? All right? I can see that x equals 1 is a critical point. But guys, what else is a critical point? 0, because 0 is undefined. So this has 2 critical points, 1 and 0. All right? It's 0 at 1 and it's undefined at 0. Those are both critical points. So critical points occur at x equals 0 and 1. I'll put them in order up here. There's my note. So I found the derivatives, right? Y prime and y double prime. Hopefully they're right now. I think they are. And I know, all right, that there are critical points at 0 and 1. Now, the next question on all of these tests, in a lot of college tests too, is, hey, tell me points of inflection. Everybody, one thing you've got to realize is points of inflection occur when the double derivative changes concavity, right? When it goes from negative to positive or positive to negative. I really can't do that until I do concave up, concave down, all right, for letter F. So I'm going to wait on letter D, and I'm going to move D, please, oh good, down to this. Because if I'm doing this on a test, this is the point on the test. I'll do the entire page so you guys can see. This is the point on the test where I'm not going to do increasing, decreasing separately. I'm not going to do concave up, concave down separately. I am going to do, in points of inflection, I'm going to do all the last 4 parts together. All right? And I'm going to do that through a table, right? I'm going to make a sign table. And I'm going to dig the information out for all the parts here now. All right? So I have the first derivative, the second derivative. We'll get that out of here. And I know that the next part is all 4 of these. And I'll do this in a different pen color. We'll do it in purple today. Because I want to know where y prime prime equals 0, because that's going to be a point of interest for me, okay, on my sign table. So I will set y prime prime equal to 0, which is negative 1/2, and then x to the 3/2, all right, equals 0. Does everybody see that in this case, it's undefined at 0, right? There is no 0, right, because there's no coefficient. So I don't have any more points to add, all right? So now I've got that point. I group this up. There's nothing here to pick from, so I put that over here. And I just have 2 points in my sign table. And that's not purple. All right? That's not purple. There. I got f of x in my sign table, the sign of that. I have the first derivative, f prime. I have the second derivative, f prime prime. And then I usually personally put a notes section, something I can take notes. And I only have 2 points on it this time. Now everybody, usually, I think you guys know I would put 0 here, right? And I would say, oh, there's an interval to the left of 0. But there isn't this time. Because what is our domain from letter A? 0 to infinity. So I don't have to consider left of 0. I'm going to put 0 in up here. All right, and I see that the y result is 0. I'm interested in the y-intercept almost always, so I do that. I also know that the first derivative is undefined here, all right? And the second derivative is also undefined, all right? So again, guys, this is part of the extreme value theorem. 0 is an endpoint. This could be the global min or max. We're going to have to check it, right? But we'll save it for that. Now I'm interested in what's happening in the other intervals, okay? So at 1, we know that was a first derivative, right? 0. And I look at my second derivative right here. And you guys notice it's negative 1/2 times x to the 3, 1 over x to the 3s. Guys, it's always going to be negative, right? The coefficient's negative. We're putting in positive numbers. It's always negative. All right? So at this point, and again, you might have to print some rules from the review sheet, that Google Doc. I know I sent you links sometime back. We know from the second derivative rule that when the first derivative is 0 and the second derivative is negative, you have a local max. All right? And we can prove now that the sign on the first derivative had better go what? If it's a local max, it better go positive to negative. And everybody, we think about this function. It makes sense to us that the number's getting bigger negative, right? But so I'm going to check it. We're going to try 1/2 in the first derivative. You know, and you can use your calculator and just go 1/2 raised to the negative 1/2 power minus 1. And everybody, I'll tell you right now that if you plug that in, you're going to get a positive number. 1/2, the square root of 1/4 is 1/2, right? 1 over 1/4 is 4. 4 minus 1 is positive. And then you plug in a big number like 8 or 9, 9 would be better. Square root of 9 is 3. 1/3 minus 1 is negative. So we have a local max here, either by the second derivative rule, right? First derivative is 0, it's negative. Or we can say by the first derivative rule, it goes from positive to negative. So I have a local max. Now, if I want to know the value of that local max, if I actually want the value of the max, I got to go back to the original function. 2 times square root of 1 is 2. 2 minus 1 is 1. All right. I think that then I have enough information now to start really doing everything that I need to do for letter E, F, D, and G. All right. Is there a sign change on the second derivative? No. It's just always negative. It's always concave down. So everybody, there are no points of inflection. So letter D is none. That is the answer to letter D. All right, there wasn't a sign change. Then it says it wants the intervals of increasing and decreasing. Well, it's increasing when the first derivative is positive, and that happens from 0 to 1, right? Not including 0 because it's undefined. All right, and then I see it's negative from 1 to infinity. That's the decreasing interval. Finally, we're concave up, concave down. I think we already said this. Since the second derivative is negative, it is always concave down from 0 with an open thing. So this is concave down only from 0 to infinity. It is not concave up. Now, if you want to write null set, you can, or just say, I just labeled one interval concave down 0 to infinity. I take that. And the final thing now is to sketch the graph without using your calculator. All right? And again, the best way I probably can do this is a dual page. And I've been having a lot of problems with my board today, so what I'm going to do is I'm going to cheat and do it a little differently than I've been doing. I'm going to put my table on that side, my blank page on the other. In fact, the graph on the left side here. So, again, I label my axes, Y, and I suppose I don't need to be in the center, do I? Because we know that it doesn't go in quadrant beyond the x-axis here. So here's my x and y. Finding the y-intercept 0, 0 helps a lot. We'll put that on there. Finding the local max at 1, 1 helps a lot. All right. We know it's, since the local max and the derivative is 0, right? Right there on that other page. We know it's concave down. And it's going to look something like that. Increasing from 1 to 0, 0 to 1, decreasing from 1 to negative infinity. No, positive infinity. 0 going to the right. 0 to infinity. It goes to negative infinity, but we're talking about the interval, the x domain. Okay? And the last thing here, I suppose I could ask for is the x-intercepts, right? We have this x-intercept. If you want to find this x-intercept, you'd have to go back and factor. Man, my board is really acting up. And you'd have to go to the original function. I'll do it over here. And factor out the square root of x. And I think you can see when I do that, that 0 is a factor. We knew that because of the y-intercept. But also 2 is a factor where the other 0 is, if you cared. I often don't ask for that, but that would be something in pre-calc we did all the time. And we've just graphed a function. We have talked about increasing, decreasing. We talked about the first, second derivative rules again. And again, guys, you have to do a little practice with this, a little studying, okay? And we'll keep sketching curves. And again, this is an interesting little curve, nothing special about it. Now, what is it? See, now, this comes back. Range is hard. Now I look at the graph, and the range is easy. Yeah, it goes from negative infinity to 1 for a range. So I come all the way over. I hope it writes here. I've been having problems. It goes from negative infinity to positive 1, including 1, right? And we can only really get range from our graph. We can only really get range from our graph in this case. So there are other ways, but that's the way to do it. And we've done a little curve sketching of a composite function that had a polynomial and a run. All right. Whoops.